Hello YouTube, today we are going to change the disc brakes and the discs on my Peugeot 206. We had a warning last time on the MOT that it's a bit low, so it's definitely going to fail this year if I don't do it, so doing both front sides today. So these are the tools I'll be using today. Just a set of sockets. We have, you can probably do this with a screwdriver, but I want to kind of do it so I don't cause any damage. This is a universal kit for rewinding calipers. You can get universal ones, but I think I've seen a few reviews where they don't fit, so this one fits every different type. So that'll be winding back the calipers. I've got a Volvo to do in the future as well, so I thought I'd invest and get that now. That's that. What I've struggled with before is sometimes you get these jobs that are quite easy, and they're made complicated because of a bit of rust or some sort of other issue, wear and tear. So I've learned previously, always clean your bolts before you undo them. I've had it before where I've not cleaned it, undone a nut, all the rust is impacted, and then I've just not been able to take it off and I have to take it to a garage. So doing it properly this time, nice set of brushes, a bit of lubricant, a bit of to take off the nuts and break down some of the rust. We've got my disc brakes here. This is a star bit set, which is what you need for some of the calipers to take them off. We've got some copper grease, which is resistant for heat, so you can put it on the actual, not the disc, but on everything else in between, so where the wheel meets the disc to stop any break, any squeaking. Got some cleaner just there. There are some settings. I'm normally quite happy just to give it a bit of a tight, but I have a torque wrench there to get the settings completely right when I put the caliper and the wheel back on. There's my discs there, I bought them quite a while ago. I have a 4-ton jack, which absolutely weighs about a ton, weighs about 4 tons, and that's about it. So hopefully that's all I'm going to need. Hopefully no problems, but you never know with these cars. Get started. Now to get these off, these are just caps. You have to use some pliers. Unfortunately, it does cause a bit of damage. A new car would probably get some specialist tool that doesn't cause damage to this, but I mean, saying that, if you do it properly, it's not too bad. So take them off. So before we lift the car, we've just got to break the nuts. Be a little bit careful with your key. I've actually rounded one of these off before on the other side. I think I put it on a bit too loosely, rounded it off, and then I had to drill the nut out on a previous video, which was a bit of a nightmare. So be a little bit careful. Right, there's always something with these cars. It's never simple. So the last time I did this, the other side, I thought maybe I put the key on incorrectly, and then kind of warped the locking nut. So I thought it was my fault. This time I was really careful, put it on straight, same thing's happened, it's not budged whatsoever, slips off it, and now it's rounded off. So now I'm going to have to drill this out. I don't know whether it's down to the metal degrades or, I mean, I did that perfectly. It's always something with these cars, but now I can't get it out, so I really don't rate these keys at all. I mean, there's not much, it's not much to deform the metal in there. That went on perfectly, so I'm now going to have to drill this off, so the job's more complicated already, but nothing I can do really. A new set of tools. It's not something I wanted to do. It's almost inevitable when you do something on a car. In principle it's really simple, but it's always something that goes wrong with rust or something, so not unusual. So I've done this before. You basically have to kind of use some quite high quality drills to go into the metal. It wasn't too bad last time, to take it slow, and then hammer one of these in and then turn it. And I'm going to replace it with an ordinary wheel nut because no one's going to steal these wheels, so that's what we're doing now before we do everything else. I've done this before. What happens is that this is just like a safety fascia or whatever you want to call it. That will when I drill that will fall off, leaving just like the threaded. I'm going to get it right in the middle and then I can turn it. So it wasn't too bad last time, but it's a bit of a pain. Just taking it slow. First hole in. I'm going to gradually go up to the largest diameter I can. So next one. Now what I would say is I'd say go slow with this, because the last thing you want to do is break off your drill bit in the hole, because it's obviously hardened steel, it's going to be quite brittle. So go quite slow, loads of lubrication, allow a lot of the shavings to come out, just take your time because you don't want to create a bigger problem. There you go, so the end falls off. That's completely normal, that's just a safety thing. It's just the actual thread you want to get out. So now we can work on what we're going to put the screw remover in. Right, so I think that's deep enough now. So that's the maximum width. And it's pretty deep, as you can see in there. So I want to use the thickest one possible. So what I'll do next, I'll hammer that in as much as it can go, give it a turn, and that should be out. Let's do it. An adjustable spanner, and hopefully that should be okay. Now I do get a bit worried about this, that this is going to shatter. I don't think it ever will, but I've just got no idea how strong it is. It's made for removing bolts, but also I'm putting a lot of force on it, a lot of leverage. It's basically doing what the bolt would have done in the first place. You turn the head and the inside turns, but I just got a fear it'd go wrong. But it didn't last time. There was a bit of movement in it, but it seemed to be okay last time, but just taking it slowly. Right, worst fear, if it can go wrong, it will go wrong. I can't believe these are made so they can break. It's really tight in there. I had no choice. So, not sure what to do now. The only choice, I think, I'm not sure how hard this is, but try and drill that out and try and get some really heavy duty bolt remover, nut remover, and see how we do. But it's such a nightmare. Everything's a nightmare on these cars. So an attempt to get this nut off that I struggled with yesterday. I had a look online and people were saying the only thing hard enough would be a tungsten carbide burr. So I'm going to give this a go. The only issue that might be that I'm not sure how good it is cutting top ends. Obviously it would shave down things pretty well, but not sure top end, so it might be I need a different shape, but I'll give that a go. And then these had a really good rating for bolt extractor, so I think I have got this out before with my ones that you saw break yesterday, but they are quite cheap. If I can get this one in, I think that is as good as I can do it really. So if I can get that end in, hopefully it's the right size for a bolt. I'll be sure don't kind of start drilling into the threads, and that is the plan, so let's give it a go. Now that's really tough. I mean, that was just a couple of revolutions and it's already done extensively more than what the drill did. Just whether it's the right shape, so definitely strong enough. It does cut at the front. I had no problem at all. Okay, so the next thing we're going to try to get this nut extractor out is going to be I've got some further burrs here, which might do a slightly better job of digging in a restricted area. Most burrs are meant for shaving off the side. I was hoping these ones would come with an end cut, and they didn't. So I was looking around at something that would be kind of literally for the purpose of well, drilling stroke milling, and I found one of these tungsten milling end bits. Obviously I wouldn't necessarily use it just for drilling holes, it's for milling, but you can take the end off. The only issue I've just found out, obviously this is a nut that's going to replace it, and they're about the same thickness. So the last thing I want to do is to use that and actually strip out the threads. So I'm going to be a little bit careful. Obviously you've got a slightly fatter bit there, so I'm going to be a little bit careful. I might try these first and see how we get on. So it is cutting through, a bit slower than I thought it would do. It cuts better at a slower speed, and there is actually a little bit of damage to the end of the bit. Obviously it's very hard, so it can kind of shatter and splinter, but I'm a little bit surprised by that. We'll see how we get on. It is obviously cutting through quite a hardened steel bit, or wherever the bit was, the nut extractor. But yeah, quite surprised that it has done that. I'm going quite slowly. Let's see how we do. A quick go with these again, just to see if they would make any impact at all, and nothing at all. I mean, this nut extractor was so hard, it wouldn't even scratch it. So these burrs made a bit of a mark on it, but they don't penetrate enough. And this is getting through it very slowly, but it's the only thing that's going to cut through that. So just a really slow process. I put a bit of oil in there every now and then, go very slowly, and just hopefully the drill's up for it. I'd imagine these drills should be able to kind of take 60-70 holes, and it's sustaining quite a lot of damage just through the one, so I might do a bit of research about why that is. Maybe it's made for a lesser steel. I mean, that extractor probably made of very similar hardness material, so I'm going to put it through its paces, but keep going slowly. I'm not sure we're going to be able to do this today, because looking at the end of the drill bit, it's completely broken away now. Now I think people are going to say this is an end mill, not a drill. Obviously I'm just trying to get this job done, so I appreciate it's not made for that job, but I figured it'd be able to, if I take it slowly, get through the job. But I'll keep going till it won't chew anymore, but I think that is pretty much done. So going to be back to the drawing board, whether I just get another one of these or maybe some sort of specialist drilling carbide tip, but I don't think we'll be doing this today, unfortunately. We've made a dent, but by no means good enough to put the new extractor in. So you see now the square of the extractor that I need to remove, so that's helpful being able to see it properly. So with the failure of the first drill bit, we've got a selection of new ones, all tungsten carbide, but different. What did you say it was? Step
coating.
Different coatings.
And different number of flutes.
Different number of flutes. So I think this one's got 4 flute, and then you've got a 6 flute there somewhere, which is just more for biting, is it? Kind of bites into there.
Majority of times you use a multi-flute as an end mill, which is using it on its side rather than the end.
Yeah.
For finishing, because you get more passes per revolution.
But it doesn't bite any better.
It has less. If you look at the clearance that you've got, the amount of swarf that can allow through the flute compared with that one is greater.
And they're all tungsten carbide, obviously, so they have the risk of breaking and shattering if you don't do it slowly.
All carbide is brittle.
But what was the one, we had this one with the alloy, what was the one with the mix? There's one with the mix, wasn't there?
Yeah, that one's got...
So this is tungsten carbide, but it's got a mix, a harder mix on the outside, which is written somewhere. It's alloy something, wasn't it?
It's... The spindle on the machine that I used allowed coolant to pass through the centre of it. So you'd have a chuck that had seals on it so that the coolant only went through the middle of the tool, and a collet that grips this. Right, so you've got a collet which has got a seal on it, so the coolant can only pass through those 2 holes and then out the other end. And what that does is it guarantees coolant at the end of the cutting edge and forces the cut material, the swarf, to exit.
Yeah, it's lovely. That's obviously too big for what we're doing, and we're not quite sure what the composite at the end is, but it's going to be a coating on the tungsten carbide that's firmer, but we're not sure what it is. But that's too big for what we're doing. But I'm wondering if that's going to be the same, the same coating.
It is. They're both Delta C drills.
Delta C drills.
Yeah.
So how much would that be then?
250 quid.
Yeah, 250. So we haven't got all the ratings of the different hardness, but this one, for example, TIALN, so titanium aluminium oxide coating. What's the N stand for? Oh, aluminium, yeah. So when mixed together, they create an even harder surface than the tungsten carbide. Is that right?
Yes.
Albeit aluminium is quite soft when you mix it together. People know what they're doing. Even harder. And you can feel it in the weight, can't you? They're really heavy.
Everything that's made out of carbide is dense. It's a very dense material, but it's also very fragile.
Which is what happened to my last bit, which is just kind of shattered, probably because of the usage, how I used it. Let's see if we can get this knot off then. Go back out again. Give it a go, these new drill bits. As my father-in-law used to be an engineer, used to be a miller, so knows all about different mills, different hardness. So we're going to give it a go. Again, same kind of principle. Take a bit slower. Probably got slightly better drill bits than I had, and hopefully get that out. What I was worried, I think that mill that I had was a bit too big. It's very, very close to the thread, so the worst thing in the world would be to go through this and actually take out the threads, and then I've just got, I don't know what I'd do to solve that. So we're going to go down to about 6 mil, maybe 8 mil, maybe 6 mil, and then maybe kind of widen that out with a burr. It's looking like maybe I have to use the smaller extractor because that larger one's going to be too close to the upper limits, and I do not want to be damaging those threads. So we will see. but nice. You can see that square now, it needs to come out. Right, so we're going to go with the, what was that one again? That's the
8mm centre drill, 90 degrees centre drill.
To kind of break that nice smooth edge. And where was the so this is, oh, this is the titanium alloy, aluminium coated one. Oh, is that the right one?
Yep.
That is, yeah.
Glass.
Oh.
Yep, that just broke it straight away. Very hard.
Oh.
6 flute, multi-start, M-mill.
Okay.
As you can see, that's cutting into that.
Yeah, already. Focus. Yeah, so that was working last time. I think your one's slightly better than my one, but
It's
the principle.
Yeah.
And the speed's okay, is it? Because I was going a bit slower, but you saw the speed. Definitely penetrating. Of course, this is a different drill bit now, isn't it? Just your.
It's a 4-fluted M-mill.
That's 4-fluted.
Yep.
Same principle though. Same.
Yep. M-mill again.
I'm going to try this one because we're getting to the smaller part of the extractor now. We don't want to make the hole too big, and this seems to be the most traditional drill bit opposed to a mill. So in theory this might be the hardest.
No.
It's not the hardest. I thought you said because of the copper coating.
That's got a carbide coating. That's got a carbide. That one's got the titanium aluminium oxide on it.
Okay.
And goodness knows what they are. I can't remember.
That biting?
So
Yeah, a little bite.
is it?
Looks like it, I think so. Yeah, look, you see.
Zoom it for me. Old eyes, dark, blind.
It's that little in the middle.
Yeah.
It has, yeah.
Where's your?
So that was okay, but didn't really. Ultimately, out of all of these, I think the one that's been the best is this one with the 6 flute. That was okay, but didn't really make much of a difference. Did it? It's come out. There you go. So they're definitely the tools for the job, but you basically sacrifice the drill bit by doing it, because that's done now, that drill bit.
It's an M-mill.
No, end mill, sorry. So you're saying that if that was in a mill,
That's a drill.
that would do that, no damage, just because you get the right lubrication, the right
Yeah. 'Cause
RPM.
in essence,
Obviously, we're
if-
moving and rocking,
yeah,
and
if you can hold any of your fragile tools, because that's ultimately what they are, rigid,
yeah,
and what you're trying to cut is also rigid, then the only thing that can give is the material you're trying to cut away.
So that drill bit would be good for quite a few cuts, owing to human error. Like, you know, by the way we're using it, it's just knackered the drill bit because it's so brittle. But so that would have no problem cutting for that 40, 50 times. I think when I bought my last one, it said it's good for like 60 cuts, and it ruined it within about 5 minutes. And this one's ruined as well. But is that because the way we're holding it and
the way we're holding it, but
and the lubrication and the rem?
You have gone down over that depth, haven't you?
Yeah, but you'd normally expect a drill bit like that to do more than that, would you? But because of all the issues we've raised, but that's really good. That's out. Perfect. So I'll make that hole the right size for the extractor, and then we can give it a go.
Which is good.
So when choosing, I was going to use this extractor because I thought there's no way I'm going to break that, but the issue with it is that it's so wide. We're pushing the boundaries of, if we make a pilot hole big enough for that, unless we get it absolutely perfect, we're going to go into the threads, because it's okay for the wider thread, but it's pretty much the same thickness as that, so you can't really go any further than that without going into the threads of the female joint. So although I'd like to use that one, I don't think we can. I'd cause a bigger issue, but that one can definitely go in the middle, as you can see, and hopefully pull it out. But that one is too big. I mean, anywhere to about there will be fine if we're centre. If we're not, and you go like that, already you've damaged it. You can't even go to there. So yeah, I think we'll use the smaller one. This chewed through the bolt like anything. It felt like soft steel, so it shows you how hard the extractor was. But that was no problem at all. That was no problem at all getting through the nut. And we have a nice hole now, ready to use the new extractor. So not quite the biggest one, but not far off it. So now we've drilled out the hole. That is an 8mm diameter hole. I could put the extractor in now, but I want to give it the best chance I can to avoid snappage like I did before. So having a look at my extractors, this is just too big, and it's too big for the bolt. And if I ever tried to get the tip in, number one, I'd be using the tip rather than kind of the centre, and if I went too far, I'll be going right into the thread. So it's going to have to be this one. Unfortunately, I did want to use the biggest one. There's no way I could twist that one off, but it's just not going to work with the size of the bolt. To give it a slightly better chance, so that's 8mm. I'm just going to go in. I bought a 9mm drill just to kind of slightly open up the top, because it's not going to. Because it's kind of V-shaped, it's not going to bite all the way, it's going to bite at one point. So I figured give it the best chance I can. Anything more than 9 is going to be too wide, as you can see. I mean, I'm only really biting into this top thread here. So I'm just going to edge in the top there, give it an extra mil, and then give it a go. Now looking at the hole, this will fit quite the way in. But so will this, but only at the end. But a lot thicker, even at the end. So I think I am going to go with this one. And that's it, we've done it. Quite hard to get it straight, but there we go. So definitely recommend these. You saw that right up until the end I was going to use this one, and then I realised actually the hole would have taken it right up to there, the 9mm hole, and even this bit is thinner than the end of that one, so I'm quite pleased I did. It's interesting to have a look at because that is what you've got to deal with. So, I mean, in terms of, I was thinking, the worry I was going to have is that I was going to drill all the way into the thread and then get so close it either collapses or I end up kind of damaging the female thread in the car. But you only need to grab at one point. Obviously it's tapered, so it's only ever going to grab at one point. So obviously what you want, doesn't really matter, it's the end of that end. You could do a small drill here and then just widen it at the end to accommodate the larger bit, which I've kind of done. So as you can see there, I mean, they're all about the same, aren't they? It's only really bit at the end. So you could actually drill further on in like a 6 or a 7 to accommodate the end with the aim of biting it there. So you can use the larger one and just have small drills to taper it, knowing that you're going to bite at the end. You only need one little bite. I mean, that's probably bitten about there. So it can definitely accommodate. And I'll probably say that's right on the line. So my recommendation is to go for a 9, no more, and that will allow you to use this larger screw extractor from Irwin. What I did, rather than just kind of put all my strength into it, as you imagine an impact driver would just kind of hammer it, I was just giving it a tug, giving it a tug, giving it a tug, slightly more, keeping an eye on the metal because you do not want to break it. Those last ones, I mean, it's inevitable, they were cheap, they were hard, which means they're brittle, whereas, you know, you kind of want, I think, probably a softer metal, so it will bend before it breaks. Obviously with a drill bit you want it to be hard, but for an extractor you don't want it to be that hard. I mean, you just want it to be able to grab onto what's there, and then you want it to warp before it breaks so you can pull it out. So, success. So I might make this into its own little video. The plan really originally was just to take the wheel off and change the discs and the brakes, but I think because it's been so involved, I'm going to make this into its own little video, and then the second part will be hopefully taking the discs and the brakes off. My usual experience, again, in principle is very easy, but if any of the nuts or bolts break off, you know, these things are always more complicated than they seem. But I'll do a second video on that. But yeah, so that's my review of the Irwin Hansen and a complex method of taking off the nut. I've done it before, a lot easier. Obviously this one was a lot harder, so hopefully that's helpful to you.